All right, here we go. 3.5. We are going to take a look at 3.5 today. Polynomials in the form of x squared plus bx plus c. So if you have, just a refresher here, if you have a polynomial with one term, okay, one term, that is a monomial. Mono, okay? That's a polynomial with one term. That's like the number 2, or 3x, or negative 5x squared. That's one term. It's a monomial. Two terms, what's that called? Do you remember? Yeah, is binomial. That's right. Bi means two. Bicycle, 2 tires. Okay, this one is called a what? 3 terms is called a? Trinomial. Excellent. Trinomial. So we are going to be factoring tricycle. Okay, triangle. We're going to be factoring trinomials, and this is the excuse me, my voice is not good, so I will be cracking. Go ahead and have a laugh at it if you want. I'm powering through just for you guys. So this is of the form where the coefficient in front of the x is a 1. So this is the easiest one to factor. And we're going to move to trinomials that have an a value, or this number in front of the x squared is going to be something other than 1. That's coming next. We'll start with this. Now, I'm not a big algebra tiles guy. I'm not a big fan because they're limited in what they can do. But they are, I think they're very helpful in helping you to possibly visualize what this multiplication and factoring is all about. Sorry, Sam, take it off. Thank you. So when we have, yeah, thanks. If it's part of your Western wear today, I guess you can keep it on, but Western, you guys, this is Western? That's a Western? Huh? Are you Ken in Wild West or what? Okay. Are you like Barbie's Ken in the Wild West? Time travel? Okay. So, all right, back. I might edit that out. Okay, so when we have a polynomial in this form, when we have all positives here, like plus, we can actually model with algebra tiles. Negatives get a little tricky, so that's why I don't really use them that much. But this is helpful. So this right here, notice a couple things, that it's a rectangle. Okay, everything is filled in. It's a rectangle. There's no spaces that are open. There's no add-ons. It's a rectangle. And what we have here is we have one big square, which represents this part, c squared. So this is c squared. These long bars are c's. Each of them are c's, okay? How many c's do we have? We have 10 c's. Each of these little squares are individual ones, and we have 3 times 7 of them. We have 21 ones. So this trinomial is represented by these algebra tiles. Everyone see that? All right. Now, I've given you on the screen here the factored form of this trinomial. So we are going to be learning how to go from this trinomial to the factored form. Okay? Now, let's first examine how do we get from here to here. Well, we multiply these two factors together, and the other day we learned that we can use the distributive property, also called the FOIL method. How many of you have heard of the FOIL method? You heard that before? Okay. The FOIL method, F is the first terms. That's what you multiply first. First term times first term. That gets you c squared. Then it's the outside terms, and that's going to be c times 7, so it's going to be plus 7c. Then I in FOIL is inside terms, okay? So that's 3 times c, that's plus 3c. And then the last terms, that's the FOIL method of multiplying two binomials. And so 3 times 7 is plus 21. When you gather like terms, you see that you get this trinomial. That's how you multiply. Let's go back over to the diagram here. Check this out. Again, I notice we have a c squared. What I want you to further notice is this, that the width of this left side, that is c units plus 1, 2, 3. Okay? The length of this side is c plus 3. Oh, isn't that handy? C plus 3. The width here, or the top side, is a further dimension of c plus what? 1, 2, 3, 4, 5, 6, 7. Oh, isn't that fancy? Look at this. So algebra tiles, in a sense, give us a visual of a trinomial, and if the algebra tiles can form a rectangle, if they can form a perfect rectangle, a square or a rectangle, you know that they can be factored to two binomials. Okay? Now, if there's holes here, it's going to be a little bit tougher to factor. You're not going to be able to do that. But if this can form a full rectangle, which when you have algebra tiles in front of you, if you arrange them, hey, it's a rectangle, I can factor this. Okay. I'm going to show you today how to know that you can factor it without the tiles. But I think this is kind of helpful. So there's a connection here with the algebra tiles, the visual, the trinomial itself, and its factors. So we're looking for dimensions here. Okay. So let's do this, but I'm gonna show you. Here's a couple examples. So write this first one down first, okay? A. We're gonna expand and simplify, and I'm going to use a similar method to algebra tiles to show you how you could visualize this. Okay? So you're not gonna have to do this for every one, but I want to show you how you could visualize this. Okay? So x minus 4 times x plus 2. Okay. I'm gonna make a bit of a rectangle here. I'm gonna put x on the top side. Okay, I'm gonna put -4 on the bottom of the side here. I'm gonna put another x on top here, and then I'm gonna put a positive 2 on this side. And I'm gonna make a chart out of that. Sorry if you can't read that. That's a +2 here. So I've got x and -4, which is this factor, and on the top by x plus 2. So you can see how this is kind of similar to the algebra tiles, right? But here we're going to be able to use negatives in this way, and this might help you a bit. So what is x times x? X squared. Very good. Now, if I look at this section right here, that would be -4 times positive x. So what's -4 times positive x? -4x. Okay? Now, what's x times positive 2? 2x. And what is -4 times positive 2? -8. Okay. All right. Not -6, close. -8. All right. Now, notice how in our picture of the algebra tiles, this was the squared part. Look at that. Here's our squared part. These are x's down here and up here. Oh, these are x's here and x's here. And then these are just the ones, the constant part, and here's the constant part. So when we multiply this to get our final answer, you can see now visually, I'm going to gather like terms and write the resulting expression. X squared is all by itself. -4 plus 2 is -2x when you combine these two. And then you have a -8 over there. Okay? And when you expand this, this is what you get. Okay? Now, there's going to be, and you know the FOIL method already, so you can actually check that. X squared, boom. 2x, oh, there it is. -4x, oh, there it is. 2 minus 4 is -2, boom, got it right there. And then the last terms, -4 times positive 2, -8. Okay? Over here for B, let's do the distribution property. So this is probably what you're going to do most of the time in your head. You're not going to do algebra tiles probably. You're not going to draw this rectangle and fill in the blanks probably. You can for now, but this is probably what you're going to do. You're going to do 8 times 3. You're going to write down 24. You're going to do 8 times -b. You're going to write down -8b. you're going to go negative b times 3, and you're going to write down negative 3b. And then you're going to go negative b times negative b, which is positive b squared. You're going to gather like terms, all right, negative 11b. And then you're probably going to do this. You're going to recognize that typically you write polynomial expressions in decreasing order of x, or decreasing order of the variable, which means that the variable with the largest exponent, that term goes first. And then the variable with the next largest exponent, in this case would be a 1, that goes next. And then the constant goes last. So you're probably going to rearrange that and write it like this. Now, you don't have to. This is fine for now, okay, because we're just learning about this, but this is better. This is good. This is best. Okay, so expanding, that's a bit of a review. You should know that. You feeling good about that, expanding? Okay. Now, factoring is simply going the other way. It's going from what we have as an answer here to the question. And this is where I think that this little diagram and the algebra tiles help us to begin this journey of how to break this down. So the journey would include this, okay? Look at this trinomial. If I asked you to factor this trinomial, we would notice that it came from this. Okay, it came from x squared, came from x times x here times x here, okay? This negative 2 came from negative 4 plus 2. Oh, interesting. Look it up here, negative 4 right here, and plus 2 right here. Wow. And then negative 8 came from negative 4 times positive 2. That's negative 4 times positive 2. So hopefully the FOIL method, algebra tiles, I don't know what we want to call this. It's like a Punnett square kind of. It's just a chart, okay, a cross reference chart here. Hopefully all this is coming together, because there is a way now that we can factor with a few little rules that two little things we have to remember. So I want you to write this down as part of your notes. Okay, this is the summary of what we've seen so far, and we're going to get some practice with it. So factoring a trinomial, please write this down in your notes, in the form of x squared plus bx plus c. This is how we do it. Find factors of c. That's the constant term right here in the end. Find factors of c. That means two numbers, integers, positive, negative, whatever, that multiply to c, that also add to b at the same time. The same two factors. Multiply to c and add to b. These will be the constant terms of your binomials. Oh, it should be binomials. Okay, the constant terms of the binomials. And the variable in the binomial terms will be just the variable in the that's on the b, or just x in this case, okay? So one thing that I should mention is that factoring trinomials in this manner will give you a product of two binomials, okay? So that is a product, product of two binomials. That's what you'll get. All right. So without the help of algebra tiles or the cross-reference sort of chart there, we're going to factor these using this little these steps. Okay. So please write this first one down. Factor x squared minus 2x minus 8. All right, so first of all, I want to run through, and you can literally write this down on your notebook on the side when you first are learning this. Some of you are lightning fast, really smart, so you'll be able to come up with two numbers that fit this right away. But when these numbers get bigger, you might have to write down some factors, and that's totally fine. So factors of negative 8, I'm going to write all the factors of negative 8 down. That's going to be negative 1 and 8, positive 1 and negative 8. negative 2 and 4, 2 and negative 4. Are there any others? No. Which of these pairs also now add up to negative 2? Okay, so do you see it? Right here. These are the magic pair of factors for negative 8. 2 plus negative 4 gives us negative 2. See that? Okay, so now that we have our important factors here, now what you do is you literally go, okay, I'm going to make two binomials. And this is the way I always do it, so I would encourage you just to make your brackets. What is the variable here that makes up this first term? It's x. So you're going to have x times x is going to give you x squared. So you're going to start each binomial with the variable. And then this is super easy, guys. You put in each number as the constant term in each binomial. So that's a positive 2. So that turns into a plus 2. This is a negative 4. That turns into minus 4. And doing it this way, you've successfully factored your trinomial. Now we'll check that. Okay, we'll check that. X times x is x squared. X times negative 4 is negative 4x. 2 times x is plus 2x. And 2 times negative 4 is negative 8. Gather like terms. And do you get the original expression, trinomial? Yes, you do. Therefore, this is your answer. Just a note, okay, just a note. Please don't circle your check. Circle the answer. Don't circle the check. Some of you like always circle the last thing you do. If you circle that as an answer on a test, that is not the answer. That's the question. So don't circle that. Don't tell me that you think that that is the factored form of the original question, because it's not. This is. Okay? And that's something I do want to stress to you guys. Make sure that you're answering the questions that are asked on the tests and assignments. Reread the question real quick before you circle your final answer. Okay. All right, let's do this one. 35. Now, I'm looking for numbers that multiply to 35 and add to negative 12. So positive 35. Okay. Do any numbers jump out at you right now?
5 and 7.
Ah, thank you. 5 and 7. So 5 and 7 are factors of 35, and also 5 and 7 add up to 12. The one small wrinkle is that we have a negative 12 here. So how are we going to work that out? Because 7 and 5, those numbers don't work. But negative 7 and negative 5, that adds up to negative 12. And notice that when you multiply a negative times a negative, that does multiply to a positive. Okay? So I want y'all to notice that. It's very, very important. And that's what I do too. I look at the number and I look at this number. I don't even worry about the signs. I'm thinking about numbers that I can work with. 7 and 5. Good, 7 and 5. Now, is it positive 7, negative 5? Is it negative 7, positive 5? Is it both positive? Is it both negative? And then you take a look at the signs, and that will help you determine that. So, guess what? Z is my variable, so I got two binomials. Z is going to be the first term in each binomial. And then I'm just going to go ahead and fill in minus 7 and minus 5, and you're done. Easy peasy? Easy peasy, lemon squeezy? Okay, any questions? All right, do these two on your own. See if you can do this on your own, okay? So factor each trinomial. There you go. Let me know and let yourself know if you understand what's going on so far. Go ahead and take a couple minutes for that. All right, let's just see how you're doing with the first one. So I'm focusing on a positive 7 here, and the two sets of factors would be positive 7 and positive 1, or negative 1 and negative 7. So what adds up to negative 8 is going to be these two. And so this should be my final answer. Did you get that? Awesome. Okay. Now if you didn't get that, try B on your own. Correct what you made a mistake. Try B on your own here. I'll show you that answer in a second. All right, so factors of negative 18 that also add up to positive 7, 9 and 2, positive 9, minus 2 gets you to positive 7. So those are your magic factor pair. And a is the variable, so make sure you have variable. Don't put x, automatically put x or anything. A plus 9 times a minus 2. And if you FOIL that out, it should work out great. Any questions on that one? Good? Okay. It doesn't get much harder than that. This one could be argued to be harder, but let's see. Here's the next example. We got a couple more, I think. So you'll see that this is not in order. Two things you can do. You can rewrite the expression in descending order of the variable like I usually do. But I'm going to show you how to factor this without doing that, okay? Just so you can see the flip side in your brain. You might want to rearrange these in the future, but you don't have to. So this is how you would factor this if you didn't rearrange the terms. You would pick your constant out, which is negative 24. You'd still pick that out, and you would go negative 24. What are the factors of negative 24 that add up to this number, negative 5, that's on the D? So I'm liking 8 and 3, right? Now is it going to be negative 8 plus 3 or 8 minus 3? What's it going to be to get to negative 5? Negative 8 plus 3. Good. Yeah, it's going to be negative 8 plus 3. So this is what we're going to do. Now, the variable here is the last term. So guess what? It's actually going to be, your variable is going to be here at the end. No big deal. And we'll put negative 8 as our constant. And we have to put a plus here. And positive 3 as our constant with a plus here. Now I know that feels a little, it feels a little gross, but let's check with FOIL to see if we're on the right track, okay? So FOIL says I'm going to do negative 8 times 3 is negative 24. Then I'm going to do negative 8d plus 3d plus d squared. That's negative 24 minus 5d plus d squared. Does that look good? It does. Please note that if you did rearrange these terms at the beginning to look like this, oops, minus 24, then the process would be exactly the same. Focus on negative 24 and negative 5. And it would look like this. D minus 8 times D plus 3. And if you carefully examine this factor and this factor, guess what? They're exactly the same. A negative 8 plus D is the same as D minus 8. And 3 plus D and D plus 3 are obviously the same too. So it doesn't matter if you rearrange these, you'll still get the same answers. Okay? But I kind of like, and because you're learning this, you probably will like this in this order because it's more consistent, but it can be done. Questions? Now, I know that if you are from another country here today, you might have been taught a different way to do this with the arrows crossing. I've seen it. Go ahead, and if you have a different method to factor trinomials, go ahead. I'm all for it because I know some of you have seen that over the years. From different countries have slightly different methods. Totally fine. Totally fine. This is the one that I'm showing you, and this is how I do it. So if you're starting from scratch, then go ahead. This is great. Okay, try this one on your own. Try this one on your own. It's got a negative in front, which is a little bit different. So try this on your own and see what you can do with this one. Okay, it's going to be a little bit tricky, but I want to see if you can figure out what to do with this negative sign here. Okay, go ahead. Okay, hang on. This is a different type of question. Why is this one different?
Because the square because
it has a number in front. So this is technically not x squared plus bx plus c. But when we factor anything, the first thing we always should do is see if there's a GCF, a greatest common factor, for all of them. And is there in this one? Yes. So that's what you do first on this one. Okay? So how do we get rid of the negative and the 4 here? Let's take a negative 4 out as a common factor. Then you will get to the form that we're familiar with, okay? So this is going to be, what's negative 4t squared divided by negative 4? Just positive t squared. Ooh, I like that. Now what's negative 16t divided by negative 4? It's going to be plus 4t because you have a negative and you're dividing a negative out. Okay. Positive divided by a negative is a minus. Okay. What is it? 30. Sorry, what did you say? 32?
Yeah.
32 is correct. 32. And not a t because it's just a number and a number, no t's. Okay, good. So this is what you do with the negative and the 4 as well. So notice something. This is maybe the first time you've seen this. You've factored a greatest common factor out, but this factor you have to examine to see if there's anything further you can factor. And of course, this is a trinomial, and we got to look to see if we can break this one down as well. So don't forget about this factor, but you do have to focus on this trinomial and see if we can break it down further. So we will rewrite this negative 4. And let's go ahead and look at negative 32. Are there factors of negative 32 that add up to 4? I'm thinking 8 and 4, right? 8 and 4. So positive 8 and negative 4. Do you guys like that combination?
Yeah.
No?
No.
Okay, are there any other combinations that would work? Negative 8 plus 4. Okay. Again, we're focusing on just this trinomial, and I do have a positive here.
I was thinking.
Yeah. So don't worry about the negative outside. We are focusing on the positive here. So I'm glad you said that, because we need to just kind of forget about this in a sense, but write it down. But we'll focus on this separately. So this now becomes two binomials. T is our variable, and I have plus 8 minus 4. And to check this, you would multiply all this out and to check to see if you get the same answer. And I will do that right now. But something I want you to remember, when you're multiplying, this is very important, when you're multiplying this factor times this factor, you have to distribute. But when you get an answer here, when you get a solution for a product here, then you take that separately and then multiply it by this. So it's just the first one times the second one, and then that product times the third one, and that product times, there's a fourth one if there is, and then that product times the fifth if there is. So we're not going to do this, guys. This is very important, so what I want you to get. We're not going to do this. 4 times this and distribute it to another factor. We don't do that. That's different than just distributing it to the next one, okay? I see students do that sometimes. So this is how it's going to work to check. Negative 4 times t is negative 4t times negative 4 times 8 is minus 32. So that's what I get when I multiply the first two, and now I'm going to multiply that by this last factor. Now I distribute. That's going to be negative 4t squared plus 16t minus 32t plus 128. So when I gather these terms, like terms together, I get negative 16t. Is that what I started with?
Yes.
It sure is. That's what I started with. Let me zoom out a bit for you. So because this is the same as my original question, then my final answer is indeed this. Now that was a tough one to end with, wasn't it? Was that pretty tough? Greatest common factor, always consider greatest common factor first, okay? So GCF first when factoring, always, always, everything, every time. All right, got a little bit of time here. I'm gonna do part of your assignment with you. This is from your assignment questions, so let's get some practice here. This should be pretty easy for you guys. This is number 7, and there's a bit of a chart, so if you want to take a minute to jot down this chart maybe, you can. So go ahead and do that, number 7A. Jot that down, I'll be with you in a second. All right, so to find two integers with the given properties, this is a way of thinking about, hey, this is the product here in this column, and this is the sum. So what two numbers multiply to 2 and add to 3? What do you think? 2 and 2?
1 and 2.
Yeah, 1 and 2, thank you. 1 and 2. 1 times 2 is 2. 1 plus 2 is 3. What are the numbers that multiply to 6 and add to 5? 2 and 3, very good. 2 times 3, 6. 2 plus 3, 5. Multiply to 9 and add to 10.
9 and 1.
Yep, 9 and 1. Or 1 and 9, it doesn't matter which way you write it. So 9 times 1 is 9. 9 plus 1 is 10. Oh, these are all easy, they're all positive, eh? The tricky ones come when they're negative, but what about 10? Yeah, 2 and 5, or 5 and 2. Yeah, multiply to 10, add to 7. Multiply to 12, add to 7. 3 and 4, very good. Multiply to 15, add to 8. Yep, 3 and 5. Perfect. Okay. Now, these are only positive ones. Like I say, the trickier ones come with come when they're negatives. Let me throw a couple negatives for you. So product is, let's say, negative, oh boy, negative 18, and the sum is 7. So what are the two numbers going to be? A negative 2 and plus, okay, negative 2 and positive 9. That's right. Okay, multiply and add. Times and plus. Okay, what about negative 35? And I've got negative 2. What about that one? All right, 7 and 5, negative 7 plus 5. Those are the two numbers. Multiply to negative 35, add to 2. Okay, one more. Let's do 13 and negative, no, other way around. Negative 30 and 13. What are the two numbers there?
3 negative 10.
Negative 10.
Okay, if you said negative 10 and positive 3, that adds to 7. Negative 10 and negative 3 add to negative 13, but it doesn't multiply to negative 30. Ah, this is a tricky one. So 10 and 3 is where you might gravitate to, but this is actually 15 and negative 2. All right, before you go any further, please jot down your assignment. Here is your assignment for 3.5. Shortened classes today. You do not have school on Monday. I will expect this to be done for Tuesday. So a little bit of homework to do over the long weekend. God bless. See you later.